Okay, we're gonna write, this is 2.1, day one. This, each section in this chapter is gonna take us forever, because they have like 1,000 things packed into each section. The funny thing is this book is very well, I mean, I understand they put all the graphs in one chapter, but they overpack the sections. Chapter 3 goes a lot faster. It's about probability, stuff like this. This is the longest chapter. But we're going to take it as it comes. Today we're learning about frequency distributions. Ten four. Good buddy. All right, so I'm going to use the data with times we've been to the ER. I'm going to write it down. Hey, I'm having a problem seeing it. Can you read it to me, Noah?
10, 3, 4, 20, 1, 6, 15.
All right, everybody write it down? So a frequency distribution is basically a way to organize your data so that you can make graphs with it. So the first thing you do is you take the highest number minus the lowest number. All right, minus, that's a minus, not like a dash. And then you divide by how the number of classes that you're going to have. Classes is how many rows are going to be in my chart that I make, and we're going to do 4 this time. So I'm going to take 20, which is my highest number, and I'm going to subtract my lowest number, which is 1, and then divide by 4. Grab a calculator if you need to. Make sure that 20 minus 1 is done first, so it should be 19 divided by 4. Anybody do that in their head? What is it?
4 and 3/4.
So this equals 4 3/4, or 4.75. And then you always round up to the next whole number. Even if it's already a whole number, you round up. So I'm going to write round up no matter what. And let me explain why really quick, because this is a confusing thing. Okay, I'm just going to write this on a separate piece of paper so you don't have to write it down, just listen, okay? So let's imagine that I had this data set, 1, 5, 12, let's see, minus 1, 13, 15. Okay, so if I took my highest number and I was going to do 7 classes, if I did my highest number minus my lowest number right now, what would I have? 14 divided by 7, which is 2. Now, if I just did 2 in my classes, so I'd start at 1 and say this first class is 1 to 2. See, that's 2 numbers in this class. The next one would be 3 to 4, 5 to 6, 7 to 8, 9 to 10, 11 to 12, and 13 to 14. You see how I've got 2 numbers in each class? But there's no room for 15 in there. See, 15 is my high number, and that wouldn't fit in there. And the reason for that is because even though you think, oh, it's a spread of 14, the spread of 14 is true, but it's still 15 numbers. So if you ever end up with a whole number, you still have to boost it up. So for this one, I would have had to boost it up to a class of 3, and this one would have been 1 through 3, 3 numbers. So it's going to feel weird that way. All right, next thing we're going to do is we're going to make a table. In your notebook, it is going to be 4 down and 6 across. Like that. sometimes you might have an empty class at the end, and that's okay. Better than having something where there's no room. But this is how statisticians always organize their data. Okay, so we start with the lowest number, and you put it right here, 1. Carlos, you're writing, right? And then we jump by 5, so the next one's gonna be 6. So I'm gonna write jump on the left. By the way, this number is called the class width. Then I'm gonna add 5 again, that's 11. Add 5, that's 16. Now you just fill in the other half. What do you think goes right here? 1 to what? 5. 6 to
10.
10. How do you know?
Because that is where the next, or like, that's the last number before you jump to the next box.
Right, the next class is starting at 11, so this one must go through 10. Also notice that since the class width is 5, if I look at this class, 6 through 10, look at my hand, 6, 7, 8, 9, 10, there's 5 numbers in there, that's why it's called that. This one's 15. And the last one, because we want all of our classes to be the same width, do you see how these are jumping by 5 as well? So this one's gonna be 20. Then we do tallies for where our data is. So like 10 is 1 tally. Then 3 and 4. 20. 1. 6. 15. And a frequency is just a total of what you got. So 3, 2, 1, 1. Down here, anybody know what this fancy Greek letter is called? It's like a E with kind of sharp edges.
Do you know it or no? Or no?
Take a guess. Think about like sororities and fraternities. Name Greek letters.
There's like alpha, beta, delta,
Mm-hmm.
stuff like that.
Yep. This one's called sigma.
Sigma.
This is
Five.
sigma, capital sigma, and a capital sigma in math always means a summation, which means we're just adding up everything, which means 7. This number should match how many data points you have. So this is like your first check to see if you're doing this right, because you're gonna be real mad if you mess up everything just because you forgot a number. And there are 7 of us, including me. Next thing we're going to figure out is the midpoint of each class, and then the relative frequency, and the cumulative frequency. I'm going to write down here that relative frequency is like, not a percent, it's the number in that class divided by the total. So kind of a percent. But you don't usually write it like 20%, you'd write it like 0.2. And the cumulative frequency, do you guys know what the word cumulative means?